Kumakaway na naman si Pilapil. No, I'm just kidding. Okay. In this video, we are going to talk about the Fano plane, Pappus configuration, and Desargues configuration. But before that, first is, what is configuration? Okay, configuration is a set of points, lines, and planes related by mutual incidence between them. So in each points or in each lines and planes, there exists a mutual incident or incident between them. Okay, let's talk about first the Fano plane. Fano plane is named after Mr. Gino Fano, an Italian mathematician who is best known as the founder of finite geometry. In finite geometry, a Fano plane is a finite projective plane of order 2 and has the smallest possible number of points and lines, which are 7 points and 7 lines, with 3 points on every line and 3 lines through each point. Now, as you can see on this figure, there are 7 lines, which are line AD, the first line, line AG, second line DG, the third line AE, fourth, line BG, fifth, line DC, sixth, and the seventh line is this circle inscribed in this triangle. Okay, and also, there are 7 points. Point A, point B, point D, point C, point F, point E, and point G. So there are 7 points. And also, in each line, there are 3 points lying in it. For example, in line AD, there are 3 points on it, which are point A, point B, and point D. Whereas in line AE, there lies point A, point F, and point E. And all these lines here, there are 3 points lying on each line. Okay, and also, in each point, there are 3 lines passing through it. For example, point D. Now, the lines passing through it are line DA, line DC, and line DG. So there are 3 lines rather passing through point D. And also in point B, there are 3 lines passing through it: the line DA, the line BG, and the circle. In point F, the 3 lines passing through it are line DC, line BG, and line AE. So that is the Fano plane. Okay. Next is the Pappus configuration. So it was named after Pappus of Alexandria. Pappus is the last great Greek mathematician of antiquity. The Pappus configuration is a configuration of 9 points and 9 lines in the Euclidean plane with 3 points per line and 3 lines through each point. Now, as you can see on this figure, there exists 7 lines. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there exists 9 lines. Okay, and also there are 9 points. Point A, B, C, D, E, F, and X, Y, Z. So those are 9 points. In addition to that, in each line, there lies 3 points. For example, in line AC, there are 3 points: point A, point B, and point C. And in each point, there are 3 lines passing through it. let's say for example, the point A, the lines or the three lines passing through it are line AE, line AF, and line AC. Okay? Another example, in point D, the three lines passing through it are line DB, DC, and DF. Okay? So in addition, point A, B, and C are three distinct points on this line AC. So A, B, and C, those points are distinct. And another three distinct points are D, E, F. They are distinct points on line DF. Okay? So if there are three distinct points on this line and another three distinct points on this line, then the intersection of line AE and line DB, which is X, line AF and line CD, which is Y, the intersection of line BF and line EC, which is Z, are collinear. So that is the theorem of Pappus, the Pappus theorem. So if these intersections point X, Y, and Z are collinear, meaning they are distinct on this line. On what is that line? This line is called the Pappus line configuration. Okay. So next is the Desargues configuration. So what is Desargues configuration? Desargues configuration. In geometry, this is a configuration of 10 points. Okay? So let's count the points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there exists 10 points. And also there exists 10 lines. So let's count the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, and which is the other one? Okay, 10. So with 3 points per line and 3 lines per point. So let's say for example, in line AY, there exists or there lies 3 points. Point A, point G, and point Y. In line BE, there exists also 3 points. B, C, and E. And in each point, 3 lines are passing through it. For example, in point A, the 3 lines passing through it are line AX, line AY, and line AF. Next, for example, point Y, the 3 points passing through it are line XZ, line YD, and line AY or YA. So this Desargues configuration is named after Mr. Gerard Desargues and also closely related to Desargues theorem that states that two triangles are in perspective actually if and only if they are perspective centrally. Before we go further to this theorem, let's talk about the symmetries of this configuration. Although the Desargues theorem chooses different roles for its 10 lines and points, the Desargues configuration itself is more symmetric, meaning any of the 10 points may be chosen to be the center of perspectivity, and that choice determines which 6 points will be the vertices of triangles and which line will be the axis of perspectivity. For example, we choose point D as the center of perspectivity. Then the points of the triangles will be this one, CFE. So this triangle CFE and Z, Y, and G, this triangle here is perspective actually. So if they are perspective actually, where is the axis of perspectivity? If this is the center of if this is the point of perspectivity, the center of perspectivity, then the axis of perspectivity will be the line AX. So this is the axis of perspectivity, and the triangles are CFE and GYZ. Okay? So let's choose another point of perspectivity, the center of perspectivity. Let's say we choose point A as the center of perspectivity. Then the triangles will be B, G, C. This is the first triangle. And F, X, Y. This is the second triangle. Okay? So if this is the center of perspectivity and the triangles is BGC and XFY, then the axis of perspectivity will be this line, DZ. Okay? So that's all for this video. Thank you for watching. Kumakaway na naman si Pilapil.